Good morning, students. Chapter 5, Two-Dimensional Analytical Geometry. Example 5.30. A semi-elliptical archway over a one-way road has a height of 3 meter and a width of 12 meter. The truck has a width of 3 meter and height of 2.7 meter. Will the truck clear the opening of the archway? This is the question given. Here in this problem, two results are given. One is about semi-elliptical archway, another one is about the truck. Okay, you see that a semi-elliptical archway has a height of 3 meter. Okay, so this is the archway. It is in the form of a semi-ellipse. Okay, so according to the ellipse property, so this a dash is called the major axis. It is along x-axis. So the midpoint of a dash is nothing but the center. So that is 0, 0. Here what is given? Semi-elliptical archway has a height of 3 meter. So therefore, from the center, the highest point on the archway is 3 meter. So this is the center is 0, 0 means the highest point on the archway from the center is 3 meter. So therefore, the highest point on the archway is 0, 3. And semi-elliptical archway has a width of 12 meter. So this is nothing but a dash is 12 meter. So a dash is 12 meter. So here 0, 0 is the center. So from the center, the point A, the distance whose distance is 6 meter. From the center to the point A is 6 meter. This A is in the right side of x-axis. So therefore, this A point is 6, 0. So the same way, from the center to the point A dash, whose distance is also 6 meter. So A dash is in the left side of x-axis. So whose coordinate is minus 6, 0. So the elliptical archway has a width of 12 meter and height of 3 meter. So it is archway results is over. Next we have to go to the truck. The truck has a width of 3 meter and height of 2.7 meter. You consider the truck whose width. So from here to here the width is 3 meter. Okay, and the truck height is 2.7 meter. So here from this center the truck height is 2.7 meter. Okay, so from the center the truck width is 3 meter. So from the center, this side, right side, this distance is 1.5 meter. And the same way, left side, this distance is 1.5 meter. Okay, so from the property of the ellipse or from the given data, so we know that this a dash, that is length of the major axis, that is nothing but 2a. So in this problem it is given as 12. So therefore 2a is equal to 12. So a is equal to 6. And what is the next result given? The height of the archway from the center. So this is distance is 3 meter is given. So that is B is equal to 3. Okay. So according to the property of an ellipse. So it is the archway is in the form of a semi-ellipse. So we can use the equation of the ellipse. The equation of the ellipse is x squared by a squared plus y squared by b squared is equal to 1. Here what is a? A is 6. So x squared by 36 plus y squared by b. B is 3. So it is 9 is equal to 1. So we have obtained the equation of the ellipse. Now what is the question is asked? Will the truck clear the opening of the archway? Okay, so the highest point height from the center is 3 meter. It is in the form of a semi-ellipse. So therefore the height can be reduced. Okay, so now what we have to see, to determine the clearance of the truck, we must find the height of the archway. We must find the height of the archway from 1.5 meter from the center. So this height we have to find out. Then only we can say whether the truck cleared the opening or not. So for that, you see, from the center, this distance is 1.5 meter, and this height we have to find out. Okay, so we'll take it as y. We'll take this height as y. So therefore this point P is 1.5 comma y. Okay, so this P point, where it is? It is in the form of a ellipse. It is in the arch of the semi-ellipse. So this P point 1.5 comma y has to be substituted in the equation of the ellipse. Okay, so in the place of x you have to substitute 1.5. So 1.5 the whole squared by 36 plus y we kept as it is. So y squared by 9 is equal to 1. This 1.5 we can write as 3 by 2. Okay, 3 by 2 is nothing but 1.5. So here 3 by 2 the whole square by 36 plus y squared by 9 is equal to 1. So when you square, it is 3 squared is 9, 2 squared is 4. So 9 by 4 into 36 plus y squared by 9 is equal to 1. So you keep y squared by 9 in the left side and bring this term to the right side as minus 9 by 144. If you take LCM, it is 144 minus 9 divided by 144. So this 9, it is in the denominator in the left side. So we can bring it to the numerator. So 9 by 144. If you subtract 144 minus 9 is 135. So y squared is here. So we need y. So y you have to write, it's a square root of 9 by 144 into 135. So square root of 9 is 3, square root of 144 is 12, and square root of 135 here it is written. So it is approximately 11.6. Okay, so you have 3 and 12 if you divide, so it is 1 by 4. So 11.6 if you divide it by 4, you will get 2.9, which is 2.9. See, from the distance 1.5 meter from the center, this y distance is what it is? It is 2.9. So this height is 2.9. Okay, the height of the truck is 2.7. So therefore definitely, so the truck will clear the opening of the archway. So the height of the archway is 1.5 meter, from the center is approximately 2.9 meter. Since the truck's height is 2.7 meter, so therefore the truck will clear the archway. Okay, so we'll go to the exercise 5.5 second problem. A tunnel through a mountain for a 4-lane highway is to have a elliptical opening. Okay, the total width of the highway, here in the bracket it is given, not the opening, is to be 16 meter. And the height at the edge of the road must be sufficient for a truck 4 meter high to clear if the highest point of the opening is to be 5 meter approximately. How wide must be the opening be? See that a tunnel is in the form of a tunnel is to have a elliptical opening. Okay, see that the total width of the highway, so the highway is to be the width of the highway is 16 meter. Okay, you see that a tunnel through a mountain for a 4-lane highway is to have a elliptical opening. Okay, so the tunnel is in the opening is in the form of a semi-ellipse. Okay, so you will have the highway, the width is 16 meter. So this is the highway, this PQ is the highway opening. Okay, so this the whose width is 16 meter. So therefore this is your 16 meter. So if you consider C is the center, means C to P is 8 meter, and C to Q is 8 meter. Okay, and you see that, and the height at the edge of the road. Okay, the height at the edge of the road. So the highway at the edge of the highway, how it is, whose height is 4 meter. So why I am saying 4 meter means, you see that the height at the edge of the road must be sufficient for a truck 4 meter high to clear. Okay, so therefore at the edge of the 4-lane road, so whose height is 4 meter. So both the sides. Okay, see that this is the, what is that, opening of the highway. That width of the highway is, what is it, PQ. That is, here it is given as 16 meter. So PQ is equal to 16 meter at the edge of the road whose height is 4 meter. So both the sides, the edge of the road is 4 meter. Okay. See, if the highest point of the opening is to be 5 meter approximately. So the highest point on the arch, which is in the form of a semi-ellipse, whose height is, that highest point is 5 meter. So therefore from the center the highest point B is 5 meter. So this is 0, 0 and this is the point 0, 5. But what is asked, how wide must be the opening be? So the tunnel opening, how it will be? So what is the opening of the tunnel? That is A dash. So we have to find what is A dash. Okay, so see that from the given result. So in the previous example, A dash is given. But here the tunnel opening is not given. Instead of that, the 4-lane opening is given, whose width is given, PQ. So therefore we have to find what is A dash. Okay, so see, from the center the point P is horizontally 8 meter and the vertical distance is 4 meter. So therefore the R point is 8, 4. Where it is R? R is on the ellipse. Okay, so first we have to write the equation of the ellipse. So what is the equation of the ellipse? It is x squared by a squared plus y squared by b squared is equal to 1. You know that A dash we have to find out. So we can't find. Now we don't know what is small a. Okay, now here it is given BC is 5 meter. So therefore, according to the ellipse, it is the length of the semi-minor axis. So therefore, B, small b is equal to 5 meter. So you can substitute small b as 5 meter in this equation. So x squared by a squared plus y squared by 5 the whole square, that is 25 is equal to 1. Okay, see now here I already told CP and CQ is equal to 8 meter. So you will get the point R. So what is R? It is 8, 4. That has to be substituted in the equation of the ellipse. So in the place of AX, you have to substitute 8. So 8 the whole squared by A squared plus in the place of y you are having 4. So 4 squared by 25 is equal to 1. Okay, 4 squared is, what is it? It is 16. So 16 by 25. So when you take it to the right side, it is 1 minus 16 by 25. So here 8 squared is 64. So 64 by a squared. 64 by a squared is equal to, here you have to take LCM. So it is 25 minus 16 divided by 25. So 25 minus 16, it is 9. Okay, so 64 by a squared is equal to 9 by 25. So when you reciprocate, a squared by 64 is equal to 25 by 9. A squared is equal to 25 by 9 into 64. You need A, so it's a square root of 25 by 9 into 64. The square root of 25 is 5. Square root of 64 is 8 and the square root of 9 is 3. So therefore it is 40 by 3. So it is equal to 13.33. So A is given. A we have found now. So which is your A? From the center to A point. So this distance A is we have found, that is what, 13.33. What is asked? How wide is the opening of the tunnel? So A dash only we have to find out. So A dash is nothing but length of the major axis of an ellipse. So that is 2A. So 2 into 13.33, that is 26.66 meter. Exercise 5.5, seventh problem. A rod of length 1.2 meter moves with its ends always touching the coordinate axis. Okay, so here AB is the rod, okay, whose length is the AB, whose length is 1.2 meter, moves with its ends always touching the coordinate axis. So this the rod end A touches the x-axis, another end B touches the y-axis. Okay, the locus of a point P on the rod. So we have to take a point P on the rod. How we have to take? Which is 0.3 meter from the end in contact with the x-axis. Okay, so we have to take the end in contact with the x-axis. So this is the x-axis. This end A is only contact with the x-axis. So from this end A, what we have to find a point P on the rod whose distance is 0.3 meter. So the PA distance is what it is? It is 0.3 meter. If it's so, we have to find the path of this moving point P. So we have to show that the path of this moving point is an ellipse, and we have to find the eccentricity also. So P point whose coordinates we have taken as x1 comma y1. So the P point, P of x1 comma y1 be the point on the rod which is 0.3 meter from the end A. So therefore PA is what? It is 0.3 meter. The rod length AB, the total length is 1.2 from A to B, whose length is 1.2. Okay, and PA is 0.3 meter. So now we can find what is PB. So from the total length 1.2, if you subtract PA, that is 0.3, you will get 0.9 meter. So this PA distance is 0.3 meter, means PB distance is 0.9 meter. So next, from P, this point, we have to draw the perpendiculars PR and PQ to the x-axis as well as y-axis. Now you are getting the two triangles. What are they? PQB and PAR. These two triangles are similar. Okay, so therefore we can get BQ. What is BQ? So this side BQ divided by PR. Okay, PR, which is equal to QP divided by RA, which is equal to PB divided by PA. Okay, so I have written this result because the similarity of triangles. Okay, so here BQ we don't know, and PR. So this P point having the coordinate x1 comma y1. So therefore this distance is x1, and here PQ also x1. So this is y1, means your OQ also y1. Okay, so now BQ by PR. So now in the place of PR you can substitute what? Y1. So BQ by Y1, which is equal to QP. We know what is QP? It is X1, and we don't know RA. So therefore X1 by RA, that is equal to PB. PB we have found it is 0.9 divided by PA, that is 0.3. So 0.9 divided by 0.3. So from the similarity of triangles we have substituted the results. Now you are going to find BQ. Okay, so all the three results are equal. So take the first and the third. Okay, so BQ by Y1 is equal to 0.9 divided by 0.3. This is nothing but 3. Okay, so BQ is equal to 3Y1. So take the second and the third result, that is X1 by RA is equal to 3, right? So the 0.9 divided by 0.3 is 3. Okay, so you have to find out RA, so reciprocate. So RA by X1 is equal to 1 by 3. So from this your RA is equal to X1 by 3. So you have found BQ and RA. So what is the purpose of finding BQ and RA? Means if you find these two, listen now, BQ you have found, and RA you have found. BQ, if you know, you can find the side OB. In the same way, RA, if you know, you can find the length of OA. So now we can write what is OA and what is OB. What is OA? OA is nothing but OR plus RA. Okay, what is OR from here? OR is X1. So OR is X1. RA. RA we just now we have found. What is RA? RA just now we have found. It is, see that RA is X1 by 3. So here you have to substitute. In the place of RA is X1 by 3. So if you take LCM, so 3x1 plus x1 by 3, that is 4x1 by 3. That is your OA. In the same way, you can find OB also. What is OB? OB is nothing but OQ plus QB or BQ. So OQ is what? Y1. BQ we have found. So we have to substitute. So OQ is Y1 and QB or BQ. So here we have found what is BQ. It is 3Y1. So in the place of QB, you have to substitute 3Y1. So it is 4Y1. Okay. So OA, OB we have found. So here it is a right angle triangle. So therefore we can use the Pythagoras theorem for OAB. So therefore OA squared plus OB squared is equal to AB squared. Using the Pythagoras theorem, OA squared plus OB squared is equal to AB squared. What is OA? It is 4x1 by 3. So that is 4x1 by 3 the whole square. What is OB? 4y1. So 4y1 the whole square. AB. AB is the rod whose length is 1.2. So 1.2 the whole square. Here 4 squared 16, x1 squared, x1 squared by 3 squared is 9, plus in the same way here 16 y1 squared is equal to 1.44. So this can be written as x1 squared by 9 by 16 plus y1 squared divided by 1 by 16 is equal to 1.44. If you divide it by 1.44, you will get x1 squared by 9 by 16 into 1.44 plus y1 squared divided by 1 by 16 into 1.44 is equal to 1. Okay, so this is the nothing but the equation of the ellipse. Okay, x squared by a squared plus y squared by b squared is equal to 1. Here what is asked? It is an eccentricity is asked. So for a ellipse, the eccentricity is E is equal to square root of 1 minus b squared by a squared. So what is your b squared? It is 1 by 16 into 1.44 divided by a squared is 9 by 16 into 1.44. So 1.44, 1.44 getting cancelled, and the 16 also getting cancelled. So here you are getting 1 by 9. So if you take LCM, that is 9 minus 1 divided by 9. 9 minus 1 is 8. 8 divided by 9. So square root of 8 is 2 root 2 divided by 3. So the locus of the point P is nothing but an ellipse, and the eccentricity is 2 root 2 by 3. Thank you, students.